Okay, this is a video to go over how to graph absolute value functions and how to write equations of absolute value functions when given a graph. As a warm-up, the first thing I want you to do is to graph these 5 functions with your calculator if you need it. Please pause the video and graph those 5 now. Okay, so the first one has a vertex of 0, 2, or 0, 3, so it would be 1, 2, 3, and looks like this. Number 2 has a vertex of negative 5, 0, 1, 2, 3, 4, 5, and goes up, like that. Number 3 has a vertex of 4, 0, 1, 2, 3, 4, Number 4 has a vertex of 0, 0, but opens down. Whoop, that was pretty bad. So it looks like this. And number 5 has a vertex of 0, 0, but it looks a little wider than our parent graph. Number 6 says identify the vertex and the transformation of y equals the absolute value of x plus 5 minus 2. Well, our vertex is going to be at negative 5, negative 2, and the transformation will be left 5, down 2. If you've completed worksheet 2.8a, here are the answers. Take a second and pause the video and check your answers. Okay, today we are going to graph absolute value functions more exactly without a calculator. Everyone take a second and please write down this formula. This is our general formula that we are going to use for graphing any function in this class, not just an absolute value function. It just happens to have absolute value symbols. Later in the year, it'll have square root symbols, or it'll have a squared, or a cube, or something else. But A, H, and K are going to stay the same throughout all of these. A can make it wider or thinner. It can also reflect over the x-axis. H, and I want you to notice that it's x minus h. That minus is part of our formula, moves things left and right. And K moves things up and down. So here we go. Number 1 is f of x equals 2 times the absolute value of x plus 1 minus 3. Because it's plus 1, it's got to shift left 1, and the minus 3 is going to move it down 3. So we know our vertex is going to be negative 1, negative 3. Okay. Now, we have an a value of 2, and that's going to make the graph feel thinner, and here's how. A normal absolute value graph kind of has a slope of 1 to the right of the vertex and negative 1 to the left of the vertex. This graph is going to have a slope of 2 to the right and negative 2 to the left. So we're all going to put our pencil on our vertex and go up 2 and right 1. Now, we're going to go back to our vertex and go up 2 and back 1. The absolute value made this shape. Normally, it would have just been a line with a slope of 2, and it would have come down this way, but the absolute value took all these negative values and flipped them over. So there we go. Grab our straight line tool. You guys, everybody grab a straight edge. And there we go. Nice arrows. And that's number 1. As you write down number 2, I want you to think to yourself, where is the vertex? Okay, for number 2, it's x minus 5, and we want to remember that that minus is part of our general function formula. So it's going to be at 5, and then there's nothing out here, so it's 5, 0. So we're all going to go to 5, 0 and put down our vertex. A is negative 3, so this one is both thinner and reflects over the x-axis because it's negative. We're going to go to our vertex, go down 3, and right 1. And then we're going to go down 3 and back 1 from the other side. Uh-oh. Don't forget your arrows. Alright, now take a second, write down problem 3 and problem 4, and try them yourself. At this point, pause the video, and I'll do them in a moment. Okay, for number 3, we have a vertex. Oop, still on straight line tool. We have a vertex of negative 1, positive 4. So here we go, negative 1, 4. And because this minus sign is here, we have a slope to the right of the vertex of negative 1. Man, that's okay. And then on the left, down 1 and backwards 1. You can see this one opens down also. Number 4, there's nothing in there with the x, so our vertex is going to be at 0, 2. So I'm going to go 0, 2, and now we have an a value of positive 1/2. So I'm going to go up 1 and right 2 from our vertex. And on the other side, I'm going to go up 1 and left 2 from our vertex. Oop, oh, I thought I had the line tool. Denied. Alright. Now we have a special situation. Man, I'm having problems with this line. There it goes. So our special situation is f of x equals negative x plus 5. And this negative here is very different. Normally, if we have a negative outside, like if it was out here where the a value is, that would mean it reflects over the x-axis. But because the negative is here, in front of the variable, it's going to be a reflection over the y-axis. Okay. So normally we see this plus 5, we think to ourselves, okay, this graph went left 5. So you can imagine, I should have used some straight lines. Oh well. You can imagine left 5 would be 1, 2, 3, 4, 5, and have a vertex here, and it would come up with a slope of 1 on each side, slope of 1 and negative 1. But because we have this reflection over the y-axis, our left 5 gets reflected. So we have a point here that gets reflected 1, 2, 3, 4, 5. And now we have a vertex of 5, 0. Make it big and fat with a slope of 1. So imagine if we had f of x equals the absolute value of negative x minus 2 plus 1. Take a second and think about where the vertex for this graph would be. Well, originally we would have a vertex at 2, 1. So we would have 2, 1, 1, 2, 1, and it would be here. But now we're going to take this vertex and reflect it over the y-axis. So here's our y-axis, and it becomes 1, 2, and lands right here. Alright, now we're going to write some equations. So everyone take a look at graph number 1 and note where its vertex is. At 0, 2. Now look from the vertex to the right. What's the slope of that line segment? It goes up 1 and right 2. So our function, is going to be f of x equals an a value of 1/2 times the absolute value of x. Now h is 0, so you can write x minus 0 if you want, or you can just put x and then plus 2. Number 2 is again, we have a vertex of 0, 3, but take a second and think about what your a value is going to be. Alright, so this one goes down 2 and right 1 from the vertex, so its a value will be negative 2. And again, x minus h, for this one it's just a coincidence, they're both 0. They're not always 0. And then plus 3. Pause the video and write the equations for these three. Okay, for number 3, we have a vertex at 3, 1, so it's going to be f of x equals, and then 2 times the absolute value of x minus 3 plus 1. Number 4 is going to be f of x equals, let's see, goes left 2 and then down 1, right 1. So your a is negative 1, and it's going to be x plus 2 plus 3. So this last one has a vertex of negative 2, negative 1, and its a value, up 1, right 2, appears to be positive 1/2. So it's going to be f of x equals 1/2 times the absolute value of x minus h becomes plus 2 and then minus 1. Okay, right now I want everyone to start the home. Oh, wait, no, never mind. I lied. We're going to look at 2 word problems. Well, we'll see. Maybe we'll get 1. Okay, so the first one says, the front of a roof with its outer edges 8 feet above the ground can be modeled by y equals negative 2/3 x minus 9 plus 14. Graph the function. Interpret the domain and range in this context. Well, the first thing I want to notice is that it's a roof, so obviously it's going to kind of look like that little old school triangle. And it's got a vertex of 9, 14. So I'm just going to make a real quick and dirty graph. Like when I mean quick and dirty, it's like going to be 9 and 14. We'll pretend that's 9 and 14. So here's my vertex, and it goes down 2 and right 3. So it's going to come down somewhere here and come backwards somewhere here. So the question is, what's the domain and the range? Well, the range is actually really easy to see. The range is going to be from 0 up to 14. So 0 is less than or equal to y is less than or equal to 14. I'm starting to wish I made a nicer graph. So let's see. Negative 2/3. If we're up at 9, or we're up at 14, and this is 9, down 1, 2. So let's see. 14 going down 2 means we would go down 7 times, and across 3, so that would be 21 across. So if we went down 7 times, imagine, so what I did was I took the 14 and I'm going down 2 each time, so 14 divided by 2 gave me 7, and then I'm going across 3, 7 times 3 gives me 21. So if I go 21 in this direction, this lands us at 30. If we go 21 to the left, that lands us at negative 12. So the range, or whoops, that's the domain, is going to be negative 12 is less than or equal to x is less than or equal to 30. At this point, everyone pull out page 125 and 126 and get started on the assignment.